Hello everyone, it's April the 8th. Let's do it today. If you guys want to know any progress on my reinforcement learning, what I can tell you is I finally gave up. I gave up on the on policy, and I'm fully on with the off policy Monte Carlo method to do the actor critic architecture. However, I did find some other angles to basically make this question more interesting, because if we just solve in a grid world, right, it doesn't really it's kind of boring and without any other angles. But finally, I was able to find another angle to make this problem a little bit more interesting. So the end result is it's all right. It's cool. It's good. I haven't finished my report yet, so maybe after doing this, I'll go back to the report. But right now is for LeetCode, and also giving me a change of mind. I've been writing the report all day. All right, let's take a look what we have. A new, let's consider week 2. Oh, I always wonder how this thing works. Nice. Okay, so we're actually going to program this. We're going to give a string containing 2 to 9. 2 to 9, so the only 2 to 9 has the letters on it. Return all possible letter combinations that a number could represent. Return the answer in any order. The mapping of digit to letters is given below. 1 does not map to any. That's why I only given 2 to 9. So 2 to 3, which means all of A, all of A, B, C with all of D, E, F. Okay, so the digit's length, maximum 4, in the range of, so basically you get 2, 3, right? So all in 2 combined with all in 3, right? We won't have 4, so it's be like 3 times 3 times 3 times 3. That's the maximum. So 3 to the 4th. That's only 3 to the 4th. 3 to the 4th is like 81, like 81 in total, the maximum. Alright. So what do? I mean, we just well, go backwards. I think go backwards will be easier. Like, we pick this, and then we go all 3 for each one of these. We pick one of these and we append. No, not really. Not really. We can go from top to bottom, and then we just need to create like 2 represents ABC, 3 represents DEF, and then for each one of them, and then for each one of these, for each one of these, for each one of these, and we just combine them together. Okay, I think this is still, wow, so like what, two easy questions in a row? What is yesterday? Yeah, yesterday is easy, right? Yeah, yesterday is easy. This seems to be an easy one as well. Hey, I'm not complaining. I mean, sometimes you want something harder to, get you going, but sometimes you just want an easy pass, especially like if you have a long day, which typically is what I have almost every day. All right, let's gonna do digit letter. All right, I'll put it here, so instantiate once. It's kind of a trick to make our solution faster than it's supposed to be. So basically, we're going to do a mapping. A, B, C. Oh Lord, this is going to take a while. 3, 4, 5, 6, 7, 8, 9. Okay, so we're going to do 3, 4, 5, 6, 7. That's only 8. There we go. This is 9. A, B, C. I have D, E, F. That's way too slow, man. G. I think it will be faster. Going horizontally seems slower. Let's go vertically. We know 5 is J, 6 is M, 7 is P, 8 is T, and 9 is W. Oh! 9 has 4. Ha! Ah. And then K. Let's just do this. Let's L, M, N, O, N, O, P, Q, R, S, T. Where's the S? Oh! 7 has more. I wonder what's the reason behind this. I don't know. I don't know. 7 has more. T, U, V, and this is U, V, W, X, Y, and Lord, Z is here as well. Okay, so that's that. And we just say for D in digits. No. What we're gonna do is, well, I mean, digits is only 4. We only have 4 digits. Huh. Okay, so we don't know. So we just go 1 digit at a time, right? And the first digit, we're gonna do that. And the second digit, we can take everything from the first digit. We're gonna add something to it. Okay. So it's slightly different. The result is going to be result is this. No. Oh yes, it's fine. Result. We need a temp as well. 2 of these, and for digit in digits, and we're gonna say. Actually, we're gonna go with 1. And the result is going to be, so we're gonna pop out from the result. Wait, what's the process? We pop it out. For each one of these, we add them. After we add, we put in temp. And then, okay, so temp should be something. It should be like this, right? Result will be digit letter, digits 0, right? And then for the remaining digits, we're gonna do for and the temp is this, and for say R in res, right? And then for letter in self.digit letter D, and this has to be self.digit. And for this, in this, what are we doing? We're doing for R, so we're doing R plus we're doing temp.append R plus letter, right? So we run through, we say res equals temp. And then we go to the next one, go through everything, and coming back up. The last one, then we're going to return res. I'm not sure. I wrote it pretty fast, and then not 100% sure if this is correct. But I think the logic shall be right. Oh, we need a handle. I just saw something. We cannot do this. I think, well, we don't have the result. We don't have anything in the result, right? If we begin with an empty, then what do we do? All right, we just special case. If not digits, return empty. Huh? Special case. I mean, there's always special case. Which means we have this. We don't even have to test this because this is definitely correct. We set up as a special case. And then 2 will give us A, B, and C. So we have to fix I think all of them are here. So I'm gonna do this, and I'm also need to fix these as usual. Okay. So this is gonna be digits. All right, let's take a look. Has no attribute. I forgot to change. Too fast, man. Can only concatenate list, not str to list. Wait, R is an str? What is res? Res is... Oh, no! Got it wrong. Has to be like this. There we go. Now we pass. And then we're gonna put in here. Let's run some other tests. Let's run the, say, 4, 8, 9. What's gonna happen? Oh man, it's gonna be a long list. Yeah, I think it's fine. Yeah, this is all right. Yeah, that's all right. That's all right. It's an easy question. Easy problem. Straightforward. How should I explain this? Pick each create a mapping, right, from each digit to the letters it represents. Iterate through each digit in digits, and incrementally add the new digit, new letter to each of the result from the previous round. I hope this makes sense, but it does not make too much sense. And this, I think, can probably do something like this, right? We just say r plus let for r in res for let in self dot digit letter d. Think this shall work. I certainly hope so. Yeah, I think it does work. Can we not do this, like start from 0? Well, if we start from 0, what is our res? Res is empty. Then res is not empty then. I mean, if we start from 0 and res, let's set it as this, then I suppose it works as well. But this no digit is still an edge case. Alright? Like if we do this, that's gonna, yeah, it's gonna be wrong. So what we can do is do this. I mean, come on, like this is. Can I put this in it as well? Oh man, seriously. Nope. Nope, that's not correct. So for D in digits, I got what? What'd you get? I get D in digits for R in res. And even if it works, I don't think I should do it that way. This is good. Two levels, right? We're restricted to 2 levels. 2 levels. What What's the runtime? ON squared. Yeah, ON squared, I think. Because we just... Huh. It's actually more than ON squared, I think. I mean, you have 1 for loop, 2 for loops, 3 for loops. That's... I probably should say ON triple, right? Anyway, because they only have 4, and each of these maximum is 4, so it doesn't really matter. 28 milliseconds. Let's give me 81%. Okay, I want to record this one. I think this one is fancier than the other one. It's the same. It's the same. Don't worry about it. All right, let's take a look at the. I think it has solution. Yeah, it has solution. But it's an easy question, so it doesn't really matter. How is this median though? It's pretty. Oh, backtracking. Do you need backtracking for this? What's the point not using brute force? Wait, am I missing something? Well, I mean, brute force. Okay, I think I'm missing something. Hold on, I think. So approach needs to take in. Okay. About the constraints. Extremely small. And brute force. Okay. I mean, but what else can you do like better than brute force? All combinations. I think this is just trying to do I mean, the solution for combination or permutation in my book is always recursion. Not really backtracking, I think. But anyway, let's take a look. It says that the runtime is what? 4 to the nth. Yeah, I don't understand. Yeah, there's no way to go lower. Care about the ordering. They do care about the ordering. Alright, let's just take a look. So it says he was backtracking. If I have more, so I say I could take this, right, and you take the next one, and after you're done with this, you need to pop out, right? So like I take A and I'm done, and then when I take B, I just need to pop A out, get a B in. So I think that is the backtracking. Lock the first, solve, and then we swap. It's just solving one digit twice. It's a recursion. And then solve for the final digit. Did they say like the input is always 4? No, the input is 0 to 4. Let's go through this again. Yep. I mean, isn't this just like we don't have to do like backtrack? Just straightforward. I mean, what would you do? So we get first one, right? And then we lock in A, and then we recurse. We go to the next one, right? We get all the results, and after that, like we have an array. I have a temp array. We push this one into the temp array, and then we get a temp array into the recursion, and we go to the next one. Now we don't care about it. And once it's all done, I mean, when it's all done, it will push the value into the result. And then when coming back, we simply take the A out, and then just pop it, and then push the next one, and then repeat. All right, I think I should write it just because it's here. And what is the 4 to the n? I mean, depending on how many. I mean, it shouldn't be like the first you have 3 options, second you have 3 options. So it's like 3 to the 4th, 3 to the n. It's not 4 to the. That's not n to the 4th. Oh, 4 to the n. Yeah. It's 3 to the n. Yeah. Depending on how many you push. All right, let's see. What do people say? Recursion. One line. We can do it in one line. Reduce. KV. Oh, that's not. That's not one line. That's more than one line. Oh man. I think it's the same idea. See this? I see this too. For x in this, for y in this, x plus y. Yeah, it's the same. X plus y. It's the same idea. Hey, I think this is more readable than using reduce. Always try not to use. Oh, I've done this before. Number 17. But it's a long time ago. This is when I first started. 2018. What method did I use back then? Find combinations. Yeah, I think this is the. Is this so-called backtracking? I don't know what this is. I don't want to know. I just want to write my own version right now. I mean, it's kind of getting forced to do this because I feel bad. I mean, using this one because I think the ideal is to encourage you to think recursion, backtracking, and that type of stuff. So we always use a helper, so it's easier. So we're gonna go helper. So the ideal I have is we're gonna have the index. All right. I have a temp. It's going to be a list. And what else? We're going to have a result. Result going to be on the outside. So result going to be like this, right? And we're going to return. We're not going to return anything. So I'm going to say if index is equal to hold on, we should first do it, right? We have an index, now we have a temp, and I'm having an index, and we can push 3 things into it, right? Push 3 things into it. We're gonna say for letter in digits, not digits, self dot digit letter digits index, right? For letter in this, we are going to append it to temp, and then I'm gonna say temp dot append letter, right? And then no, it has to be this, n equals len digits. Alright, and then the thing is, if index equals n, then rest.append temp, copy it, and return. Else, we do this, we append the letter. After append the letter, we're gonna call helper index plus 1 temp. After we're all done, temp.pop. Right? So this is the backtracking. And I think that's it. Yeah, that's it. And then the same. Do we have to consider the case? Well, I guess we don't have to consider the special case. I mean, we'll start with 0, and then 0 is equal, so I append. Well, I mean, has to if temp, right? If temp, then I append. Otherwise, I don't append. So in this case, I think we can just say return an helper 0, and temp is just going to be empty this, and then we're going to return res. Let's try it. Oh my goodness, what the hell is this? Oh, that's what happens. Okay, it's append. Oh, then we don't. Then it's fine. I think it's fine. So I always forgot. We have to do it's a string, not anything else. So we do this. No, see, it's gonna be empty this. So we do have to do if temp, right? So we can avoid it. Yeah. So this is the backtracking. So as required, we write a backtracking solution here. Backtracking solution. Well, this question must be old, like really old. I'm not sure how fast. Like this 28, the same. How old is this one? I mean, gotta be older than 2018. Let's say. I mean, see what's the first? 2015. 2015. Dang, that's a long time ago. All right. Anyway, this is it's all right. It's all right. I mean, given that this is at the very beginning, so that's why they kind of set this to a medium question, but it's actually not that hard. All right, we did pretty well, and I think that's it. That's it for today. I will see you guys tomorrow. Adios.